Hi, my name is Edward Milan, and my speech is on nuclear energy. The first successful experiment with nuclear fission was conducted in 1938 by three German physicists, Otto Hahn, Lisa Meitner, and Fritz Strassmann. The first self-sustaining nuclear chain reaction was obtained at the University of Chicago by Enrico Fermi on December 2nd, 1942. Enrico Fermi was an Italian physicist, most noted for his work on the first nuclear reactor and his work on quantum theory. During World War II, many nations embarked with programs to develop nuclear energy. The Oak Ridge National Laboratory, created as part of the Manhattan Project in 1943, was established because American scientists feared that Nazi Germany was rapidly developing an atomic bomb. The laboratory and the city of Oak Ridge were built by the United States Army Corps engineer in less than a year on an isolated farmland in the mountains of East Tennessee. In 2 years, the city of Oak Ridge housed more than 75,000 residents. The goal of the Oak Ridge National Laboratory and the Manhattan Project was to separate and produce uranium and plutonium for use in nuclear weapons. Nuclear power pros far outweigh the cons. Three main advantages to this form of power generation are that it is economically cheap, environmentally friendly, and its efficiency. Currently, nuclear energy is the cheapest out of all the other forms of power generation in the sense that its overall production cost is 1.76 cents per kilowatt hour. The next cheapest form of power is coal, which is 2.21 cents per kilowatt hour, while the next form of semi-clean energy, natural gas, registers at 7.61. In addition, if European energy can be brought into the picture as well, nuclear power is clearly the cheapest form of energy. This is due partially to the number and the size of nuclear plants in Europe. Furthermore, in countries with developing economies, where growth expands faster than infrastructure, nuclear power could be the key to providing cheap power that would not interfere with the rapid expansion. Typically, in periods of time where there is a large amount of growth in a short amount of time, power, amongst other things, is in short supply. These shortages limit growth and don't allow the maximum hypothetical expansions. With power being supplemented by additional reactors, this allows for the elimination of one of the many obstacles faced by these expanding countries. In the future, assuming things don't change, the current pace and usage of the fossil fuels will not be sustainable. In addition, with rising demand on foreign markets and diminishing domestic supplies, the cost of such fuels will skyrocket. As of July 2008, there are more than 430 operating nuclear power plants, and together they provided about 15% of the world's electricity in 2007. Of these 31 countries, some depend more on nuclear power than others. For instance, in France, about 77% of the country's electricity comes from nuclear power. Lithuania comes in second with an impressive 65%. In the United States, 104 nuclear power plants supply 20% of the electricity overall, with some states benefiting more than others. Amongst other things, this will leave the country in an energy crisis the United States has not seen before. To enhance the current methods of energy production and to partially relieve the country's dependence on coal and foreign oil, the spending on nuclear could be increased. Additional funding could speed up the process of building more reactors, to provide power or possibly fund research into building larger reactors which are more fuel efficient. Nuclear power isn't the solution to the country's energy problem, but could remedy the issue for time enough until a sufficient amount of energy is nuclear power based or a different form of power becomes more preferable. From a different economic standpoint, nuclear power provides a unique advantage. The average thermal efficiency of a standard nuclear power is 35%, which is comparable to similar sized coal and natural gas plants. However, the difference comes in fuel. One uranium pellet can deliver 17 million BTUs, British thermal unit, of heat energy, which is equivalent to 1,780 pounds of coal, 17,000 cubic meters of natural gas, or 149 gallons of oil. Also, the cost of nuclear power is quite cheap in relation to the output of electricity from the fuel. At $100 per kilogram, which initially sounds expensive, but when the amount of heat evolved from just one pellet, which makes up less than 5% of a gram, is taken into consideration, the price becomes much less important. In addition, the relative supplies of uranium within the top 3% of the Earth's crust at that price will last another 50 years. However, when the price is doubled, then there is around a few hundred years of usage. Despite doubling the fuel price, this will have very little effect on the overall cost of the electricity, only raising prices 5%. However, in comparison to natural gas or coal, when prices is doubled, anywhere from 30 to 70% increases in final prices of the electricity can be expected. Nuclear power generation is unique in how the amount of energy that is contained in a relatively small amount of volume. The military applications are rather broad-ranging from aircraft carriers to mobile generators. The U.S. Navy has been using nuclear power since the USS Nautilus, the first nuclear-powered ship, soon followed up by the USS Enterprise, which was the first nuclear-powered aircraft carrier. These two types of ships are typically nuclear-powered with few exceptions. However, when contrasting the general sizes of both ships and the power demands for both, it is obvious why nuclear power was chosen. Viewed from a civilian standpoint, there are a plethora of different uses. Power generation on a macro scale is the most common, but smaller reactors have been used to power malls, schools, and even solitary homes. Hypothetically, nuclear power could be used to power transportation vehicles, but more research is needed on the safety protocols for such applications. Possibly one of the greatest strengths of nuclear power is the environmental effects of the operation of large-scale nuclear power plants. There are none. Out of all fuel-consuming forms of power, nuclear energy has the lowest impact on the environment. The reaction used for generating heat does not produce any form of byproduct. The only real external product is excess water that gets released into the atmosphere as steam. In comparison to a coal-burning power plant, more radiation is released from burning of coal than from a nuclear power plant over 50 years. Furthermore, all the water used in a nuclear power plant can be recycled either back into the plant or brought back into the environment with minimal damage incurred in the process. Nuclear power is economically cheap, environmentally safe, and produces tremendous amounts of energy. It will not be long until our supply of fossil fuels and natural gas gets completely depleted. Nuclear power can partially relieve our dependencies on coal and foreign oil. As long as the world needs electricity, however, there will be nuclear power. People will continue to discuss the issue of nuclear power for a long time to come. That's my speech.